Dr. Simon Johnson from CPI, Center for Process Innovation in the UK. Now you're on the stage with me. Welcome. So,
okay, thanks,
you are
Kasha.
the closing presentation of our conference. We look forward to your presentation. So, all good.
Okay,
You have
is that
15
good?
minutes. Yeah,
excellent. Thanks very much. Okay, well, thanks very much for the opportunity to present this short discussion on flexible electronics for health tech, and the aim is really to investigate some of the challenges of health tech devices and see how flexible electronics helps to address those challenges. Very briefly, just to explain who CPI are, we're part of what's called the Catapult network in the UK. Our purpose is to support companies in the development and scale up of new products and processes. And the Catapult network is an organization of many centers dotted around the UK. We receive UK government funding, but we work with a wide range of clients from the UK and all around the world, in fact, in multiple ways. So we're here to support industry as our key purpose. We fill a little gap in between the research and invention and the commercial market is our main purpose. So helping companies to go from I've got one that works on the bench to great, I've now launched and I've got millions of these being produced every week kind of thing is the purpose. Anyway, that's very briefly what CPI is about. Health tech devices are an interesting field, and they have lots of different challenges that we've identified over recent years when we've been addressing these issues with clients in different projects. The challenges are very diverse, and they range from things like the basic form factor to how people actually use and adopt these products. But just to go through a few of these in a little bit more detail. The form factor, the product design is a key challenge in many health tech products. Health tech products need to be very easy to use. They need to be inconspicuous, ideally invisible. You know, really customers and clients would users would much prefer these things if others didn't know they were using them, for example. That's quite common. So they need to be very lightweight, often flexible, so they will integrate with either patches or clothing, that type of thing, or things like small hearing aids that need to be as small as possible and really very compact forms and shapes. So they really are very awkward and difficult to make with conventional electronics. And power sources are another key challenge that these devices have. They often have quite high functionality requirements, and many of these devices are required to be wireless in their connectivity, but that puts quite serious demands on power sources. And yet you have a very small volume in which to have any sort of battery or power storage device. Or if it's energy harvesting, the area available for energy harvesting can be quite constrained. So power sources can be quite a serious challenge. And yet these devices need to be very robust. Often they need to be washable. They're operating in a harsh environment. The human body is actually a pretty harsh environment. We do lots of challenging things to our bodies, and the devices that we're going to use in our health tech applications need to be able to experience those environments and operate perfectly well within them. So robustness is another challenge. As I've mentioned already, wireless connectivity is a very common part of many of these devices. But this may be either within a building in your home or within a hospital, or it may be remote, and it may be necessary to connect information from a remote site through to a central data store, for example. And in that transmission, not just the physical connectivity or the wireless connectivity, but challenges such as security and data standards have to be addressed and considered. Personal data is tremendously important to users. And the security of that is essential, and there are very many standards that address this. It's essential that any sort of data transmission complies with all of these sorts of standards. And then we get on to the sort of more soft side, really, I suppose, and things like adoption and use. And this is really about the social factors and the user interface and user experience of these devices. It is very common for smart devices just to be a bit of a nuisance to people. And so it's very important that they are fundamentally straightforward to use, almost invisible to the user. And so data collection needs to